Hello, and welcome to NRG Systems webinar on data sharing and resource assessment. Let me click through here. Okay, so today I'll be going over these topics. I'll start with an intro about who NRG Systems is, for those of you who don't know, and who I am. And then I'll jump in to talk about renewable energy resource assessment, kind of in broad terms, what that exists, what that entails. And then I'll go into metadata and data standardization, specifically around the Task 43 data model. And then we'll talk about the NRG Parser open source Python library, which is kind of the main topic of today's discussion. And then close out with some links and information on contributing. So, who is NRG Systems? I did take a look at who had signed up for this webinar and saw that a lot of familiar names on the list and companies. But for those of you who don't know, we're NRG Systems. We specialize in wind and solar measurement technology, mainly around resource assessment, but also around things like turbine control, as well as bat deterrent technologies for wind applications. The company's a little over 40 years old and has really been staying in that niche for the whole time. And then me, I just moved the slide. I'm David Carlson. I'm the manager of special software initiatives here at NRG Systems. I've been with the company for about half that time, for about 20 years or so, in various roles, including field engineering and managing our technical services group, the great people over in the technical services department. And now I'm doing mainly Python and cloud service development, focused on our NRG cloud platform, which if you don't know, you can go to cloud.nrgsystems.com if you like and sign up for a free account and check it out. But it's really about fleet management, data sharing, getting data in a painless way from devices that are fielded into a cloud-based application to have easier access to all of the data from these sites. It also has some built-in features like alerting when there's a problem, so we can minimize data loss, but that's a whole different topic. The other way I tend to spend my time is working with the data science group at NRG Systems and our technical services group to support those two teams. So jumping right into resource assessment. Resource assessment. Okay. So when I have resource assessment in these slides, I'm really talking about renewable energy resource assessment, so solar and wind. You can think of resource assessment as happening over time. So you've got that horizontal line. There's different phases. There's the selection phase, which is where everything starts, and that's where you choose where you want to do your measurement campaign, the type of instrumentation used, the type of sensors that you want to use for that campaign, data, so what format the data is going to be in. A lot of that has to do with the instrumentation choices you make, but even with any particular instrumentation choice, there's going to be ways to configure the formatting of the data, how data transport's going to happen, whether it's going to be stored just on site and accessed once a month via snowmobile, if that's the best way to do it, or if it's going to be something that's more of an automated transfer, which is typical over cellular or satellite. And then storage, how is the data going to be stored, both short-term and long-term? And then how is the data going to be shared? So those are kind of the what part of the selection. And then the who is the partners involved. So which OEMs are you going to be working with? Which installers are you going to be working with? Whether it's a single outfit that has a broad regional coverage, or if it's somebody who's more specific and by project, you use a different installer by project. Who are the local technicians? So certainly with solar resource assessment campaigns, there's a lot of maintenance that has to be done on a regular cadence, so understanding who your local technicians are, and then further down the road, who the consultants are that you're going to be working with once the data is collected and on for its next step. So for data collection, that's the next step. So that's kind of the longest running step of a streamlined campaign, I guess, at least. And that takes time. Data collection for a wind resource assessment campaign may take a couple of years. For a solar resource assessment campaign, I know less about that, but something on the order of a year or the like. And during that collection phase, there's a lot of activities that are going to happen. Of course, there's data quality checks, which may be done on a weekly or monthly cadence. Sensor cleaning in the case of solar resource assessment, which typically happens weekly, as I understand it, or bi-weekly. Monthly reporting may be a part of the collection scheme. And of course, site maintenance has got to happen. So in the case of tower-based wind resource assessment, site maintenance has to happen on an annual or preferably semi-annual basis to make sure that all the guy wires are in proper shape, the booms are tight and angled the right direction. But sometimes there'll be some unplanned maintenance that occurs along the way as well. But just to say, as all these things are happening during the collection phase, data about those events are being collected and need to be a part of the packet associated with the time series data from the resource assessment campaign. And once the collection phase is done, verification involves making sure that all of the data is properly completed, all of the metadata is in place, all of the calibration information for the instrumentation, that was kind of a rhyme there, is all there, ready to go. And this is where a third party will likely be involved to do an independent analysis of the data. Some people who work in that field may be watching the webinar now, so I don't want to speak too far out of turn, but there's a lot of work involved in the verification step. And then the last step, of course, is the submission step, where that packet of data, metadata, certifications, sign-offs are all handed off to the financing agent, whether that's the financing agency, whether that's a private agency or a public bank, or it's a government that's distributing funds based on tenders or something like that. But that's going to be the last phase of a typical resource assessment campaign. And resource assessment, I mean, it can look as simple as a single tower. And when we think about that long timeline, thinking about that in terms of a single site, it's pretty straightforward. Even if you don't have everything aligned and all the T's crossed, you can get there. But as you add towers, add different instrumentation setups, maybe all four of the towers in this picture have this exact same sensor configuration, but there will be some differences between them that need to be accounted for. Maybe it's the terrain or the site-specific information. If it's on a different landowner's property that has, restrictions, different access restrictions or whatever, every site's going to be a little bit different. And then if you add in other instrumentation types, like in going from a tower-based wind resource assessment campaign to adding some LiDAR in the mix, they're inherently going to have a different data set and a different way of using the data. And then you could have entirely different resource assessment campaigns that might be part of the same project if it's like a wind plus solar project. So you can see how, once you get up to 12 sites or so, we could be talking about some real complexity here. And then, best case, you kind of have this single line that represents the course of a resource assessment campaign. But in many cases, there may be this additional step, which is foreseen or unforeseen, where the project is shelved for a period of time due to something blocking it moving forward, whether that's permitting or financing or landowner access, or maybe the technology isn't quite there yet. But after some time, it could be picked back up, moved into the verification and submission steps. In this case, the data collection, whoever had collected the data initially may be gone from the organization. Maybe no longer available. So, any questions that are in place about the data are going to be a little more difficult and costly to answer. And people drive the entire process. So every time there's a handoff, every time there's a personnel turnover, it can make an opportunity for something getting muddled or a bit flipping or something like that. So just to point out, there are some places in a resource assessment campaign where complexity can become magnified. Jumping into the topic of metadata. So metadata describes the time series data in our case. So when we're talking about resource assessment data, you have sensors that are collecting data over time. They're collecting statistical data, sometimes real-time data, and that data has to be described. So we need to understand the sensor and logger information, details about the site, whether it's location, topography, vegetation, access, ownership. We need to understand the data format, the column naming convention, and what each column of the time series data represents. We also need to understand events to ensure that things have been done according to best practices and the commissioning was done properly, site maintenance was done properly. When there were issues identified with instrumentation or sensors, they were mitigated. That all has to be a part of a resource assessment campaign's metadata package. On the left, you can see some screenshots from a Symphony Pro text export. So you can just see the first 70 lines or so of that export. There's site information, there's channel information, a lot of stuff that's not a lot of fun to read, especially if you have to read through this data again and again and again to find errors or to verify that everything's right. It's the kind of work that computers are really good at, but as a person who's done both the automating of this and the actual verification of some of this stuff, it's a lot nicer when you can have a standardized format that is less error prone. So again, this is a Symphony Pro text export. Different OEMs have different approaches. So in the case of Symphony Pro, when you do a text export, you end up with this metadata information block at the top of the file, and then after that, the time series data starts. But other OEMs and other devices may have metadata in a separate place, in a separate file. There's advantages and disadvantages to both approaches, but I just wanted to call out that it happens. There are different approaches. So that's where data standardization comes in and can simplify all of this. Again, I'm talking about resource assessment, data standardization, data models. I'm not going to spend a lot of time talking about data models and the Task 43 format because the team that's working on that project, kind of headed by Stephen Holleran, they have a lot of great resources, a lot of good textual resource, as well as some recordings that you could look at if you want to learn more about how that all works. But here I did want to touch it on a high level. So a data model is something that leads us towards that standardization. It's something that describes the entity's attributes and relationships of the data. It's something that creates consistency across data sets. So every time there's a new Met tower, like in that image I showed earlier, it can be configured in a way that the data can be compared between them. And a data model, in our case, we want it to be as generic as possible while specifically geared toward whatever we're using it for. So for us, we're talking about wind and solar energy resource assessment. Some non-resource assessment examples that are out there, like cloud optimized geotiffs. So those make it easier to access these great big geo images, but just accessing a part of it without having to download all of it. So that's a great way to create efficiency. This analysis ready data. It's something I'm not that familiar with, but one of my colleagues mentioned it as being one of these examples of a success there. I'm just going to scroll down and jump into IEA Wind Task 43. So like I mentioned, I'm not going to go too in depth on this, but I'll highlight a few things that I think are pertinent here. So this is an open source, I should have said data model. Hey, well, we'll do some live editing. Data model for wind resource assessment. So initially it was done for wind resource assessment. I saw in the notes of a meeting in early December that the team was talking about broadening or genericizing the verbiage around it to make it more around wind and solar resource assessment, because it's really applicable in both areas. There's a GitHub page where is really the hub, if you will, for all of the information around this project. It's the digital WR data standard. And just this is a screen cap from the main page there. I'll click over to it in a second. But the main page here shows on the left sort of what an analyst might see in terms of a PDF or a commissioning report that includes sensor information. And then on the right is more of a computer ready format that has a standardized key value pairing system for all of the metadata associated with the site. I've mentioned metadata several times. So this WRA data standard is really about the metadata. It's not so much about the time series data itself as describing the time series data and validating it and fully fleshing out what the data is, how it's instrumented, what the tower configuration is, all sorts of information. So can I control click? Yes, I can. Great. So here is the GitHub page. It's accessible. It's open. Anybody can get in here. You can see I started already if you're using it, if you're finding it useful. The main page here has code. It's a Git repo. So if you're familiar with Git, you can clone it that way. You can also download it directly if you want to just play around with the files. I just wanted to highlight the demo data area has some JSON files that are fully fledged and show you how a fully filled out metadata file might look. It's long. It's like 1,700 lines or something like that. So there's a lot of data in those JSON files. And also the schema here. So if you wanted to create a database to go along with this at home for fun or in the office because you want to adopt a standard, which is really what the whole idea behind this project is, there's information on how to stand up like a Postgres database here. But then there's some really good reading down here that's pertinent for anybody who's on this call. I encourage you to go to this website and check it out, read a little bit about the data model. There's some links that go into more depth on data models. There's a screen cap showing, here's a screen cap I copied. No, I guess that's on another page, but there's a lot of information here on the IEA Wind Task 43. And then I also wanted to click on this file. So this is a JSON file. Whenever you view JSON, if you open a JSON file in a browser like Firefox, it does some nice things, like gives you these little collapse options. So it's a little easier to parse through. But you can see at the head of every JSON file here, we have some information about the plant. And the plant is a kind of a bigger picture of, typically in the NRG world, we use the term site. But plant is something that may be worth migrating to because it's a little more on the nose here. Measurement location would be, maybe it's more like project, because measurement location, so this would be a tower or a station or a LiDAR would be this measurement location. You can see this particular data set only has one, but there may be multiple measurement locations that have their own lat and lon, the station type, whether it's a mast or a LiDAR or something like that. Properties about the mast, whether it's a lattice triangle or some other type like a tube, which we're familiar with over at NRG. a bunch of stuff about geometry. Then we get into logger main config, which is going to show some familiarity for people on the call, like what's the logger model serial number, who's the OEM, what are we at for firmware version, things like that. And then measurement points are really like sensor locations. Is that right? No, I may have that wrong. No, measurement point would be the logger on this thing. Or this, maybe it's the whole site. Sorry. Again, I'm speaking a little bit out of turn, going to the folks at IEA Wind Task 43 for more information is really the place to go. But I did want to show some things about the logger measurement config. So here we have like, here's 0 and here's 1. And these give us some slopes and offsets for different channels. So anyway, I'm kind of meandering here, but getting back to our presentation, the idea here is to have a standardized format for a complete data set. And then for us at the NRG side, as the OEM, the equipment and data OEM, we want to be able to take the data output that I demonstrated in that those metadata screenshots from SimPro data and turn it into this Task 43 data format. So we have an open source Python package called NRG Parser. Right now it supports the Symphony Pro data logging format, but it's open source. So if anybody wants to add more, they can send feedback, let us know which logger types of ours you want thrown in there. We do have plans to add more to it over time, but understanding the urgency for folks on the call is really helpful for us, so we know where to fit that into our backlog. And this was a cool project because this NRG parser actually didn't start at NRG. It started with one of our customers, and they wanted to develop this and then hand it off to us. So that's what we've done. They've developed a code to parse the text outputs from Symphony Pro loggers and put it into the Task 43 format. And then I took it and turned it into a package that can be installed from pip, which for those of you who are on the call who are working with Python, pip is the package management tool that you can just pip install NRG parser and it'll be installed on your computer. So from there, I'll just go on a quick tour. So this is the IEA Task 43 logo I stole from their site. This is NRG, of course, and here's the Python logo. So I'll click over to the NRG Parser package. So this is a Python package, so all the things about it are here. If you scroll down, there's some good README information on the source, the documentation, so you could click here just to see how to use it, as well as the Task 43 GitHub page here. Installation is as simple as pip install NRG parser. Assuming you're working with Python already, I do have an NRG intro to NRG Pi. If you wanted to, let me just quickly open this because it's pertinent here. Go to the repos, and there's this intro NRG Pi package. So if you're interested in Python and NRG Pi, this includes a link to a webinar video that I did a while back. And it includes instructions on how to get started with NRG Pi. So if Python is new to you or kind of new or you haven't done it in a while, I'd recommend you go to this intro NRG Pi website, check it out. But back to the parser page here. Yeah, this is where it goes. The other thing that it has is an example notebook, which I'm going to jump to now and just quickly kind of show it. And that will be most of what I wanted to cover today. So for those of you familiar with Python and Jupyter Notebooks, here's one. So this has some information on how to just quickly use some of the features in the NRG Parser tool. So I'm just going to step through. I'm going to import the NRG Parser package. I'm going to make a metadata object here. So what I've done is I'm just calling this SimPro text reader with a path to a test file that I have here. And then I'm going to get some metadata from it. So when I say get all metadata, it populates some attributes to this metadata object, and then I'll just click through them. So the header information comes through, and I can see where it came from. The logger main config comes through, so then I can see things like the serial number, the model name, the logger ID, logger name. So all this good information here that's in the format of the Task 43 data model. And then the config dict list. So dict is for dictionary. So yeah, all this data comes through, and it's all just parsed automatically so that you don't have to come up with your own tool to manually take text file data and turn it into Task 43 data. I kind of glazed over this stuff. A lot of the information is in the docs for the NRG Parser app here. So if I click on the documentation, you'll see it takes me to another page that includes some information here, and I can go through all of the topics. So not to go too long in the tooth here, close out by talking about following up. So if you want to be a part of Task 43 or the NRG Parser application, we're always open for input. You can go to the repositories here. I'm sure the links will be in the write-up for this webinar. So these are, open source projects that we're hoping will benefit our customers and the industry at large. Use and start the repos, participate in the discussions. So, as we look at these GitHub pages, click around, there's active discussions going on, certainly with the IEA Task 43 WRA digitalization standard. There's a lot of activity. I think it's like a bi-weekly or a monthly basis that there are meetings there that anybody's free to join. And then if you find issues with either the standard or the repo that we have, please either post an issue or contact me or NRG. So hopefully you found this topic useful, insightful, fun, inspiring. However you took it, I'm sure is fine. If you want to get in touch, please reach out. Otherwise, thank you very much for watching, and I look forward to hearing from you. Take care.